Hi guys! So we're back in the meth lab again this week for some simple demonstrations of redox or oxidation reduction reactions, and we're going to be doing those with one of my favorite chemicals, which is copper 2 sulfate, or cupric sulfate, or just copper sulfate. And the thing I love about it is this bluish green color. And really one of my favorite substances to work with in general is copper, because everything is this beautiful like green blue. I'll show you some of the... This here is copper chloride. It's more of a greenish color. But isn't that nice? Look at that. This is copper carbonate, which is actually a solid. It's kind of a greenish powder. And this one's probably my favorite. This is actually copper acetate. And then copper 2 sulfate itself, that is the actual solid that I've dissolved in here to make this solution, is this beautiful dark blue crystal. And really concentrated copper 2 sulfate actually has this really dark blue color, and I like it even more. This is not very concentrated, so it's just more of a light greenish blue color. Now I'm going to start off first by taking our solution of copper 2 sulfate and just giving it a quick swirl to make sure that we've dissolved any residual solid here. And then I'm going to take just a little bit of ordinary table salt and sodium chloride and add it to this copper sulfate solution, and all that this is doing is increasing the electrolytic nature of our copper 2 sulfate solution, which will help it conduct the electrons a little bit more readily in our redox reaction. And we'll swirl that a little bit just to make sure it's all dissolved in there. You can do this reaction without the sodium chloride, but it tends to be a lot slower and the results tend to be less impressive. Alright, now I'm going to finally put these shot glasses to use. I'm just going to portion a little bit of the copper 2 sulfate in each of these glasses. I'll try to keep it even here. Look at that, perfect. I should be a priest. And now what I'm going to do is take 4 different metals, and I'm going to place these into our glasses containing the copper sulfate solution. So the first metal that we're going to be working with today is just aluminum, and I'm just using aluminum foil. So we've got a little piece of aluminum foil. I'm just going to flatten it out a little bit, and then we're just going to place it into our first shot glass with the copper 2 sulfate solution. Okay. Next, we're going to add some zinc. This is a small piece here of zinc metal, and that's going to go in shot glass number 2. There we go. Shot glass number 3, I'm going to add a small piece of iron, and actually it's probably hard to see on this camera, but this is another example of a redox reaction. We can see that this iron has been oxidized by the oxygen in the atmosphere to form iron oxide, which is more commonly known as rust. I'm going to try to bend this so we can submerge it completely here without giving myself tetanus. Alright, and that goes in glass number 3. And finally, in the last glass, I'm just going to put a piece of copper wire. And we're going to see what that does. Now, I ended up making way more copper 2 sulfate than I really needed, which does not surprise me. But I'm a firm believer in doing things that are cool on a very large scale, so we're actually just going to pour the remaining copper 2 sulfate into this beaker. So we're using this much bigger piece of zinc. This is actually from one of the electrodes that's inside these 6-volt lantern batteries. So if you open one of these up, there's 4 of these cases inside. And we are going to take this now and submerge it into our copper 2 sulfate solution. So let's see how our metals are doing now. Here's our aluminum, which we can see is now coated with this kind of reddish brown solid. Let's move over here now. We're looking at the zinc. And this likewise has this kind of red brown solid. Here you can see the zinc itself is kind of broken apart. Here is our iron shot glass, and you can see that the iron wire is now coated in this brownish red coating, much like the aluminum and the zinc. And then we move on to our last shot glass, which contains the copper wire. The copper wire appears to be relatively unchanged. So if I remove the residual aluminum and any of the copper 2-sulfate solution that's left unreacted from the shot glass, you can see just kind of the reddish-brown solid copper metal that is now in each of the shot glasses, with the exception of the one that contained the copper wire. So now we're looking at that much larger beaker containing that larger zinc electrode from the battery submerged in the copper 2-sulfate, and we can really see the redox reaction. See, that copper is completely coating the zinc. You can see all of the copper that's accumulated here on the bottom of the beaker. And then check out the copper there that's floating right at the top of the zinc casing. So what all these reactions have in common is that they are all oxidation, reduction, or redox reactions. So what happened was, in each reaction, the copper ion, or the cupric ion that was in the copper 2-sulfate, and those copper and sulfate ions go into solution. It's what we call an electrolyte. Once that copper ion, however, interacts with another metal, what we would call a more active metal, that copper is reduced from that cupric ion to solid copper, which is that reddish-brown solid that manifested itself in each of the shot glasses, and then, of course, here on a much larger scale, in this beaker. Now, as that cupric ion, or that copper 2+ cation, was reduced to solid copper, that bluish color of the solution began to disappear. And we didn't see that so much in the shot glasses, but you can really see it here, where a solution that was originally a very deep blue-green has now become almost clear, as all of that copper cation has been converted or reduced into solid copper. Meanwhile, the active metals like zinc, aluminum, and iron were oxidized. They lost electrons and went from the solid form of the metal into the metallic ion. The only shot glass where we didn't see a reaction was the one where we put the copper metal in the copper 2-sulfate, because in that case, copper is the same in terms of reactivity as copper. So copper isn't going to oxidize or reduce itself. In other words, there's no redox reaction happening there. Copper is actually one of the least active metals. In fact, the only metals that I can think of that are less active than copper are gold, platinum, silver. There's other ones. But as you can see, or as you might be able to guess, I don't have any platinum, gold, or silver down here because it's very expensive. Anyway, this will be my last video before Christmas, and New Year's. We'll be taking a couple weeks off. So everyone have a fantastic break, and we'll see you again in the next year. We'll start off again with Painting of the Week, finish up the Garden of Earthly Delights. Have a great break, everybody.